Hi, everybody. Is everyone here? Can you hear me? Can everybody hear me?
Yes, we can hear you.
Okay, I was passing out the quizzes and worksheets. So if you have quizzes or worksheets to pick up from me, come by my office and I'll be glad to give them to you. There's a whole bunch of old stuff that wasn't collected yet. So that's what I was doing while you were there. But basically my plan is today is to continue where we left off and kind of introduce a new subject to you. And then essentially the plan is to have the exam be on Monday, and I'll have a worksheet as a take-home quiz for the weekend for you to work on related to chapter 4. So basically the exam will be on Monday regarding that. Are there any questions, those of you that are virtual? Anybody have any questions?
So the exam is on chapter 4?
Chapter 3 and chapter 4.
Okay, thank you.
Okay, any other questions? Yes. Okay, someone here answered, does any of the stuff from the first exam cover over to the second? And yes, it would be the foundational stuff like balancing equations, etc. So elements and such like that. It just all fits together. But it's not going to be anything anything I didn't already ask or wasn't covered in chapter 1 and 2. Okay.
What time Monday?
It'll be 7 o'clock for the group 1 people, 8 o'clock for the others, but we have five athletes that are coming in at 8, so 5 of you can come at 7 o'clock if you wish, but we can sort of have rotate in and out there. So if some of you want to come at 7:30, we'll just let you in as other people leave, but there will be room, so we can kind of break it down as you did before. Any other questions? Okay, all right, so what I'm going to do now is continue where we left off. I want to essentially, I'm going to be introducing a new subject to you that is relatively straightforward, and I do want you to take it seriously, even though it'll become more clear when you have electrochemistry and general chemistry too. But basically, this is a good place to introduce the subject when we get to it. So it's called oxidation reduction reactions. Okay. And what I'm going to do is add a couple slides to kind of introduce the subject to you here as well. Talk about 2 different aspects of this. So I'm going to add some slides here and then start the thing here regarding this. So you'll see a blank slide to start. So I'll now share the screen with you folks. Please let me know you can see it. Okay, can you see the screen there?
Yes, we can see it.
Okay, wonderful. All right, now what I'm going to do is kind of combine what you're learning in lecture as well as in lab, and kind of talk about different kinds of reactions, okay? And basically different books break it down into different places, but it'd be very useful for you to kind of understand that what happens regarding the nature of reactions, okay? The first type of reaction is called a synthesis reaction. And this is where you have A plus B goes to AB, okay? So for example, you can have lead plus sulfur goes to form lead sulfide. And you got to balance it, so you put it like that regarding that. So basically, this is one example of lead sulfide thing. The reverse of that is called decomposition. And decompositions essentially are like going lead sulfide goes to lead plus sulfur, okay? Or you can have all sorts of other examples, like calcium carbonate with heat gives calcium oxide plus CO2, which is a gas. Does everybody see the relationship there between the synthesis and the decomposition? What's the difference between both of those reactions? This is AB goes to A plus B. What's the relationship between those reactions? Correct. They're like the reverse of each other, okay? So basically you can have a combination of them, okay? The next kind is what's called single replacement. And this is where you have A plus BC goes to AC plus B. Now what gets replaced? What gets replaced? Yeah, which one? Which one's going to get replaced? The B. The B will get replaced, and essentially you get that. An example is one you've seen before with the zinc, with the hydrogen experiment, HCl, and you have two like that, goes to form zinc chloride plus hydrogen gas. So that's an example of the breakdown of the thing. Now, what's being exchanged? What's being changed? What did you say? Sorry. C? No, C is the same for both. Yeah, the A gets changed to B, and this will be related to the next part of this chapter that we're going to talk about, okay? And then the next one's called double displacement reaction. Double displacement. And we've already been talking about that already, okay? And all these kind of reactions, the mole ratios and what we learned in chapter 3 fit in very well of going grams to moles to grams, or the stuff in solution. And an example of this is AB goes plus B, plus A, oops. Double displacement or double replacement. Okay, and basically this is AB plus CD goes to AD plus CB. And so you can kind of see what's exchanged with that. And an example of this would be silver nitrate plus sodium chloride goes to form silver chloride solid plus sodium nitrate. And these are in aqueous solutions. So you have AQ for each of these. This is the precipitation reaction. So there's a whole bunch of different reactions that take place in this. Now, the first part of the chapter 4 that was covered in Chang in the PowerPoints was precipitation reactions. Precipitation reactions. And I'll get to it a little bit more in either today or tomorrow, okay? So basically, this is an example of a precipitation reaction where essentially it goes like that. But that's a double displacement. That's a double displacement reaction where you have that, okay? You also have a neutralization reaction, and that's what you're doing in lab. Because essentially you have HCl plus sodium hydroxide goes to form sodium chloride plus water. And essentially that's the same thing as what you used with a different acid, which was the acetic acid in the labs we're doing this week and last week. Okay, so there's a direct connection between our lab that we're doing this week and the kind of reactions that occur thing. Now, the thing that's weird, Chang kind of covers this thing after this next section that I'm going to get to on the next slide, but I'll finish up with that tomorrow, probably. But the big thing is with these, they all fit together as part of the logic of chemistry, and working these details out is kind of useful. Now, the other part regarding precipitation reactions, you can have gas formation, okay, and that would be like the calcium carbonate one I gave you earlier. Here, we have a gas formation reaction. This is a decomp, okay, so there's decomps that occur in there. And also you can have precipitation, neutralization, and then what's called oxidation reduction. Yes. Well, that's what you're doing in lab, reacting the vinegar with the sodium hydroxide. And have you had lab yet? Okay, do you remember the pre-lab thing where I showed you the combination and it's a double replacement reaction and you form water and the net ionic equation is with this H plus OH goes to form water. Oh, because so he introduced it a little differently?
Yeah, we just kind of went to, he explained the titration.
Oh, okay. Well, I gave a little bit more lecture to my things. If you want to come to it this afternoon at 1:30, you can. Okay? If anyone else is in, Dr. Gerhardt wants to do the same thing, come at 1:30, you can, okay? Today, I'll give the same one I did to everybody, but we'll cover it a little later in this, on the slides too, okay? But the way the slides are laid out and the slides for our textbook are not very useful because they're just the charts. And I'd rather have you follow the logic of it, okay? So, so basically oxidation reduction is the next part, okay? So now what I want to do is essentially with this, and I'm going to kind of put an eraser on this so I can erase some parts of it. And all the material is on the video, so you can watch the video later, but I want to erase the stuff on this so I can add some more stuff to kind of introduce this to you. Okay, when you have an ion, like say for example, sodium, in its normal form, it is a solid. It's like it's a metal. Okay, when it loses electron, when it dissolves in water or something, loses electron, it becomes sodium plus one electron. Okay, essentially the electrons that are going around the thing, just like the hydrogen has one electron around it, goes to form the hydrogen plus one electron. If you remember, the hydrogen as the proton in the center with the electron going around it, it's just a matter of this thing leaving. Okay, so when you have, this is called the oxidation state. Okay, so essentially oxidation is removing of electrons or taking away the electrons, and essentially here, this reaction is called oxidation. And the number goes from 0, sodium 0, up to sodium plus 1, okay? And there's a bunch of different examples which I showed before, like lead, 0 can go to lead plus 2, or lead plus 4. How many electrons did it lose to go to lead plus 2? 2 electrons. How many did it lose to go to lead plus 4? 4. Okay, same thing with tin. So tin could also be plus 2 and plus 4. Okay, zinc is always plus 2 or 0. Okay, so there's a whole variety of ones that only have one of them associated with it. Silver's plus 1. The oxidation is going up in one form. Now, if you have tin that's plus 2 and it goes down to form tin, 0, because you add 2 electrons to it from a source, okay, this is called reduction. Now, I'd like you to think it in this context. What does it mean when it's going from plus 2 to 0? What's happening to the number? Just think about the number. What's happening to the number when it goes plus 2 to 0? It's going what? Down. That's called reduction or reduce, okay? So it's easier to remember the reduction part until you understand what we're going to cover in chapters 5 and 6. But the big thing is with this, the oxidation part is it's losing electrons. The reduction part means it's gaining electrons, and that's what the next slides are going to be about. So I wanted to kind of put everything in context for you so you can see kind of where we're going with that. And again, I apologize for my handwriting. I did the best I can, but it adds a little to the slides if I explain it a little in context. So any of you have questions before I introduce the topic? Anybody virtual have questions on what I put on the 2 slides? Any questions? How about you folks local? Any questions? Okay, so let's go to the next thing, okay? Oxidation reduction reactions, these are electron transfer reactions. So essentially here you have magnesium, which is 0. It goes to form magnesium plus 2 to form this compound. This is the compound, okay? And then it has 2 electrons associated with this. Now, each electron is -1. So look at both sides of the equation. You have the +2 and the -2 times -1. What's that total? Nick, what's that total? When you have 0 on the left and then +2 and -2, what's that make? No, +2 and -2. No, 2 minus 2. What's 2 minus 2? 0, great. So the 2 minus 2 is on the right because you have 2 electrons and it's 0 on the left. So the key thing is here, and this is what's called a half reaction. You've lost 2 electrons. So that's the half reaction that's occurred. Is that an oxidation or reduction reaction? What's happened to the, it went from 0 up to +2. Well, yeah, it lost 2 electrons, but it went from 0 up to +2. What's that mean? It's oxidizing. Yes, so it's an oxidation reaction. Okay, going reduced means it's going the other way. So for example, if we have tin plus 2, and you add 2 electrons to it, and then it goes to form tin, the metal, what's that? You're adding 2 electrons to it. It's going from +2 down to 0. So what are you doing there? It's reducing. It's going from 2 down to 0. Reduce. Okay, so that's called a reduction reaction. This is a reduction reaction. Reduction, sorry. Okay, so this is the other half reaction. These are both half reactions. You have the oxidation here, and then the reduction down there. Yes. Well, just by it treats the individual electrons differently. Some get added, some get removed. And that's the nature of bonding, which we'll talk about next chapter. Okay, the forming of ionic bonds means you exchange electrons from one to the other. Like say, for example, sodium is 0, plus you add chlorine to it. This is an oxidation reduction reaction 2. This is synthesis, so you have sodium chloride. Okay, the sodium goes from 0 up to +1. +1 for sodium. The chlorine goes from what? The chlorine goes from 0 down to -1. And there's 2 of them. So you have 2 -1s there, okay? So that's essentially what's happening to the chlorine. The chlorine breaks and then you get a -1 for each one. And that'll become clear in chapter 5 why that happens. -1. So you have magnesium, which is +2, and then the chlorines, which are -1 each. And you have 2 of them associated with this. And that's what you have the solid magnesium chloride there in the box. The solid thing right here. That one, the solid. Okay, that's your forming, like you're reacting magnesium with chlorine gas. And there's a whole bunch of different examples of showing that kind of reaction taking place, okay? And an example of that would be like just burning paper. It's reacting with oxygen. The paper is reacting with oxygen. That's an oxidation reduction reaction too. That's why it's called oxidation when you burn something, or it's called oxidation when iron rusts. The iron goes from 0 to +2 or to +3 when rust forms. Yes,
So oxidizing is giving electrons. And reduction
giving
is-
electrons up. Yes, it's losing them,
Yeah, and reduction is taking.
taking them. Yes, and that's the nature of bonds forming.
But here, you're adding electrons. So
Well, that's why you have two halves make a whole. So there's two parts of the reaction, and I'll talk about the half reaction in a minute.
yeah, but I'm saying, like, you're adding, so with magnesium, you're
Yeah.
adding the 2 electrons.
Yeah, it's losing 2 outer electrons, just like a hydrogen, just like the hydrogen, when it goes to form an ion, H+, you have this here and the electron going around it, okay? You have the plus proton in the middle, and essentially the electron just leaves, and you're left with the proton in the center. That's with the hydrogen atom. But the other atoms are a little bit more complex, and some electrons can go off of them. That's why metals conduct electricity. They've got a lot of extra electrons there. Okay, does that kind of, you'll understand it as we get to chapter 5, but right now I'm just kind of helping you understand what oxidation is and what reduction is, okay? Because that's the 2 parts of that reaction, okay? So now let me get rid of the stuff on the slide and we'll use what's there. Okay, so here the magnesium essentially loses 4 electrons. You see this here? This is what happens. This is the oxidation part. That's the half reaction for oxidation. Okay, and then these gain electrons there. And in this case, the oxygen looks like this. It's a double bonded thing, and you'll learn this in a few weeks. But basically, it splits up to form the oxygen -2, which looks like this. 2 of them. So essentially, you have 2 of them associated with this. And essentially, this bond breaks when you're forming just an oxygen atom to react with the other one. Okay, so you've got an oxidation reaction, and these are both half reactions associated with this. So let me erase what's on the slide again, 2, and move again to the next thing. Here, when you combine the 2 reactions, these are combined together. What did he essentially do on this slide? He added both things on the left, right? So essentially you have this plus this. This plus this, and then this plus that. And then you have that there. What is common to both sides? The 4 electrons. They can be removed because essentially, have they disappeared? No, they just exchanged partners. Okay? And you can kind of look at it this way. If you have kids, and each kid has 2 books. Now, let's just use my sons as an example. One of my sons is 2 years older than my other. We would give him books when he was little, okay? And my younger son would get them also at his level, okay? When he grew older, my older son, instead of sharing a book, would give it up happily to the other one. That's an exchange that worked for both of their sake, okay? Or they could share it. If they both wanted 2 books and they were old enough to understand it, they could share it, like we did with the Lord of the Rings, Tolkien books, or the Chronicles of Narnia. We didn't combine, we didn't get each copies for both of them, but they each had their own individual things because they're 2 years apart. My granddaughters are twins, a little 3.5 years old, okay? So they share a lot of stuff, okay? Because one, they got the same academic level or whatever else. I don't know how to describe it, but the point is they like sharing a lot of things, but they get their individual property as well, whether it be a little dolly or whatever else that they have, okay? They each have their own preferences. But the big thing is, it happens the same way with atoms. If atoms want to form a bond, they can either give up electrons and take them, or they share them together to form a different kind of bond. That's called ionic and covalent, and we'll get to that later. But now we're just talking about the specifics of the reaction, which is called oxidation reduction reaction, okay? And then you go to the next one there, and that's the compound. So now you have the final compound of the reaction. What kind of reaction is this based on what I showed you before on the previous slides? This is called a synthesis reaction. So synthesis reactions almost exclusively involve oxidation reduction. Okay, and they're a very major part of the reactions that take place in chemistry. Now, for example, there's a lab you'll do next semester, hopefully in Gen Chem 2, that essentially involves making a battery. And for example, if you have a zinc metal put in copper sulfate, essentially what's going to happen is the zinc will give up electrons to the copper, and then you've got a copper, it changes to copper in the beaker. When a piece of copper wire is placed in silver nitrate solution, the copper enters as copper +2, the silver's converted to solid silver, where that happens. So essentially, the copper wire changes to solid silver. That's an oxidation reduction reaction as well. That's just an example, but there's plenty of examples you can see on the internet. But believe it or not, oxidation, the best ones that are most available are essentially burning, because you're essentially having anything react with oxygen to form. So essentially you have, let's say, hydrogen plus oxygen goes to form water. Okay, that's an oxidation reduction, okay, because essentially the hydrogen has gone from 0 to +1 for each. The oxygen has gone to 0 to -2. Okay, so you have, this is reduction here, reduce, and this is oxidation. Okay, so you have two kinds of things related to that. Yes, you had a question? Okay. So basically here, now let's look at a specific example of zinc and copper sulfate. Okay, zinc metal is put in a copper sulfate solution to form zinc sulfate plus copper. Now, is it easy to balance this reaction? Is it balanced? Yes, it's balanced because you have the same number of things on both sides, okay? But this could be split into half reactions to help understand this. If you look at this, this is 0 and this is +2. So you put down essentially this here. 0 goes to zinc +2, +2 electrons over here. Yes?
How do we know, that's what I'm confused with, like, how do we know that zinc is 0 and zinc sulfide is 2?
Just because of what you did in chapter 2 when you were naming compounds, and they kind of introduced the whole concept of oxidation state based on where it is on the periodic table.
Okay, so that's just,
Right now, that's just it. You will come to understand that in chapter 5 and 6, because it has to do with what's called the electron configuration around each atom. And some give up and some thing, and some are shared. Yes.
Yeah, but I thought isn't just zinc by itself +1?
Well, it's going to be, it's now an aqueous solution. It's an aqueous solution. It's surrounded by water molecules when that happens.
On the left, the reactant side,
Well, you have the zinc solid. It's a solid form. I'm just breaking it into halves. This is called the oxidation because it's going from 0 to +2. This is oxidation. And that's the half reaction, okay? The other one that happens is copper goes +2 down to copper solid, which is 0. So where the 2 electrons go? On the left, 2 electrons. Okay, so essentially this is the reduction part. The combination of both of them gives you that one at the top. So basically when you have and work these kind of problems, you break them down into the half reaction to balance them, because you're balancing the amount of electrons going in both directions. Okay, so that essentially will show what's going on with that. So now I'll go back to my picture.
I just don't understand where you get the numbers from. Like, how is 1 copper 0 and 1 copper plus?
Well, it's because if you remember what we talked about in chapter 2, talking about the transition metals, copper has a +1 for copper 1 chloride, and then +2. Those are losing of electrons. And as I was saying before, we will come to understand that. So in chapters 5 and 6, it'll become very clear in chapters 5 and 6.
I understand that, but like for the test for Monday, we're gonna have to know how to do that.
Well, it's just a matter of looking at the form and remembering what you learned regarding putting the compounds together in chapter 2, regarding oxidation state and having the periodic table. If you remember the periodic, let me draw it on here. If you have the periodic table, oops. And I kind of asked you to kind of, if you remember the periodic table looks like this, okay? And we have the +1 here, +2. This is where it comes in, okay? And then the +3, and then plus or -4, and then -3, -2, -1, 0. Remember?
Yeah.
Okay, so that's, we're adding to that right now.
I understand that, but the transitional metals, like,
They can be +1 all the way up to +7.
yeah,
Because they lose electrons, and it has to do with the d orbitals, and we're going to get into that in chapter 6. But right now, this is kind of introducing the subject to you. Huh?
but I mean, but like there's different numbers for each.
Yeah, well, right now, I'm just asking you to trust me and realize this will fit together when we get to it. Unfortunately, you can't fully understand it until we get to chapter 6. Okay, yes. Well, just because you can add things up and look that the solid will always be 0, and that the sulfur you already know is -2, based on what you learned in chapter 2. I'm not going to pull any. That's why you're going to work on homework problems, and on the exam, I'm not going to pull any fast ones on you by giving you tricky ones you haven't seen. Yes.
So we just assume that it's 0 if it's by itself.
If it's by itself, it'll always be 0. Yes, that's essentially what's happening. It's always going to be 0 when it's by itself.
Will it always be 2 if it's in a compound?
Yes. Zinc, yes. Yes, it will. No. It could be plus. It depends what the compound is. Like, say, for example, hydrogen is always 0. When you have an element, it's always in its normal form, it's 0. Sulfur, S4, 0. P4, 0. They're all 0 in their normal form. Okay? But when you form them in a compound like HCl, that's +1 and -1, like we learned in chapter 2. Okay? If you have sodium like this, sodium carbonate, this is -2 and this is +1 for each, and there's 2 of them. And we put those together with that. If you want to go back through the worksheets and try them and see them again, you're welcome to do that, but that'll help you understand how this works. And that's why I gave you all the worksheets, so you could understand what the ion forms were. And when you're working the homework, you can use those charts that's in your textbook too. Okay? Yes.
So the zinc in this case is +2 because SO4 is a negative.
Yes. Yeah, but zinc will always be +2 when it's a compound. There is no +1 for zinc. And you'll come to understand that later when we talk about it in chapter 5 and 6. Okay. So what I want to do now is continue to go through this example, and then I'll stop and give you some homework to work on tonight that'll help explain this a little more. Okay. Well, you can work on the book for this tonight. But essentially, the copper gets added 2 electrons to it. This is the oxidation part. This is the reduction part. So you have both of them working together there. The zinc is oxidized. Zinc is the reducing agent. The copper is reduced. Copper plus 2 is the oxidizing agent. Okay, so they're agents, and what's being oxidized is a zinc in this case. So you have a combination of different factors associated with each. Copper wire reacts with silver nitrate to form silver metal. And this is the kind of problem you're going to get. So why do you help me with this, Brandon? Copper wire, what do you put down for that? It's solid copper. So what are you going to put down for it? We're going to do the formula. Right, so it would just have copper. Okay? So essentially the copper solid plus the silver nitrate. And notice this is a single replacement reaction. Okay? You essentially have A plus BC goes to AC plus B. Single replacement. Okay? And that's an oxidation reduction reaction also. So the copper is going from copper to plus 2. Okay? That's being oxidized. You see it? Okay? And this will all become clear when we get to understanding the nature of these things later. Okay? So it will become clear. Okay? And then the silver is reduced. Silver plus is the oxidizing agent. The oxidation number is the charge the atom would have in a molecule or ionic compound if the electrons are completely transferred. In other words, electrons are given up by metals. Given up by metals. That's why they conduct electricity. They have a lot of extra electrons there. You pump in electrons, you'll get electrons out the other side. Okay, free elements have an oxidation number of 0. Okay, these all have an oxidation number of 0. Monatomic ions, the oxidation numbers to the charge of the ion. So, lithium is plus 1. Ferric, or iron 3, is plus 3. Oxygen is minus 2. And you just put the oxidation number of oxygen is usually minus 2, but in some cases it's minus 1. So oxidation number is very, very important in this. The oxidation number of hydrogen is plus 1, except when it's bonded to metals and binary compounds. In this case, it's minus 1. And then these 2 slides, if you want to print out these slides and work on them, that'll help you understand it also, because you'll kind of see the logic of it. But I just recommend you just use the periodic table I give you and put the numbers over top like you did before. Okay, and then the sum always equals 0 for a molecule or done. Oxidation numbers do not have to be integers, so they could be there. So what are the oxidation numbers of all the elements in there? So let's just try that. The hydrogen is what in this ion? Plus 1. The oxygens are minus 2 each, so there's 3 of them. Okay? So that's minus 6. The oxygen is plus 1 and minus 6. Okay, the whole thing is minus also, so that's a minus. So essentially you have minus 6 and then plus 1 there. So essentially you go through that step here. The oxygen's minus 2. The hydrogen's plus 1. 3 times that is the total there. The carbon is going to be plus 4 to give minus 1. Okay? So oxidation number, and essentially that's from the periodic table there. And then there's a bunch of examples here in each of these compounds And essentially, if we look at them here, the sodium is +1, the oxygen is -2 each. Then you figure out what the total is there. And so that means -6 + 1 is -5. So the iodine is +5 in that case. And then there's a bunch of different examples given in the book. This is Chang. These are PowerPoints for Chang, but this is in Hein also. There are slides regarding this also in Hein. But I'd recommend first reading the chapter in Hein first, and then go to this part of our book, and you can see that as well. Any questions? Okay, we're done for the day. Yes.
What is the question mark when you're solving for the charge beyond?
Oh, that's just what is the number that fits in there. That's the variable. That's the variable. Like you put the 5 in there, that's 1 + 5 and -5. So it's 0, the total 0, that's all. Okay? Okay, that's a good stopping point. If you have any questions, I'll be glad to go over this with you in the class. So, okay, we're all done. So thank you very much, and I'll see you folks tomorrow. Thank you all, everybody.